Welcome to Mr. Leek's free science.
Welcome
tutorials.
to Mr. Leek's
free science tutorials.
Now, the question that we're going to be dealing with in this
what is the difference between an atom?
What is the
an
difference
element,
between
a
an
compound,
atom,
and
an
a
element?
And
this is really the fundamentals
starting of chemistry.
You need to understand
starting
the
of
difference
chemistry.
between these.
You need to understand the difference.
So, what is the difference between an atom?
So, what is the difference
an element,
between an atom,
a compound,
an element,
and a mixture?
A compound and a mixture.
Now, this table summarises the difference between them.
Summarises the difference.
The very smallest part of an element.
The very smallest
part
of an element
that can exist
is
the
an
tiniest little part of it.
It's
right,
the
tiniest little part of it.
It has a radius
right,
of about 0.1 nanometers.
There's a radius of about 0.1
So that means
nanometers
the
and has
electrons
no
on the
charge.
protons.
So that means the
electrons on the protons are
An element contains only one type of atom.
contains only
So if
one
you've got lithium,
type of atom,
right, that is
So
an
if you've got
element.
lithium,
Sodium,
right, that is
an
an
element.
element.
Oxygen,
Sodium,
that is an element. Oxygen,
Bromine,
that is an
that
element.
is an element.
Bromine,
And there's around
that is an
100
element.
different elements.
And there's
each
around
one
100
represented by a
different
symbol.
elements, each one
Another key to
represented
this
by a
is that
symbol.
Na.
Another key
right,
to this
is
is
one
that
element.
Na,
and it's capital N
is
little
one
a.
element.
If
and
you
it's
write
capital
down
N,
little
little
n,
a.
if you
in an
write
exam,
down little
you might
n,
get knocked down on
in
your
an
marks
exam,
for it. You might get
if you write a
knocked
capital
down on
A,
your marks for it.
if you
You
write
might
a
also
capital
get
A,
knocked down marks for it.
you might also
So
get
it has to
knocked down
be
marks
a big
for it.
letter and a
So
small
it has to
letter
be
if it is two
big
letters.
letter and a small
O
letter if it is
is
two
obviously on
letters.
its own.
O.
Then what you have is you have a compound and a mixture.
Then what you have is you have a compound,
A compound
and a mixture.
is where
A
two or more
compound
elements are
is where
chemically
two or
combined.
more elements are
So if you think
chemically
about it, that is then
combined.
where you've
So
got
if you think about it, that
two
is then where
things
you've
that
got
are literally stuck
two
together.
things
right,
that are
stuck
literally
together,
stuck together.
right, and
Right,
it
they're
is
stuck
very,
together,
very difficult
right, and
to
it's
separate.
very, very difficult.
So
to
compounds can
separate.
only be separated
So
into
compounds
elements
can only be
by chemical
separated
reactions.
into elements by
So the only
chemical
way to really
reactions.
split up a compound,
So the only way to really
H2O,
split up a
water,
compound
is
so
hydrogen and
H2O,
oxygen.
water,
The only way to
is
split
hydrogen
them
and
is
oxygen.
using a
The only way to
chemical
split
reaction.
them is you are using
And
a
they tend
chemical
to be very,
reaction.
very difficult to do.
And they tend to be very, very
A
difficult
mixture
to
is
do.
where two or more elements
A mixture
or
is where
compounds
two
are
or
not
more elements
chemically
or
combined.
compounds are not
A really good example of
chemically
this
combined.
is
A really good example
sulfur
of this
and iron.
is
Sulfur is
sulfur
like a
and
yellow
iron.
powder.
Sulfur is like a yellow powder.
Iron is kind of like a dark brown.
Iron is kind of like a dark
crystals,
brown,
not really crystals,
sort of
but like
crystal
little filaments.
They're
of
not really
iron or
crystals,
pieces
but like
of
little
iron.
filaments of iron. Or
Now,
little
what you
pieces
can
of
do is
iron.
you can react them together.
Now, what you can
Right,
do is you
where
can
they
react
be
them
chemically
together.
combined,
Iron
iron
sulfide,
sulfide,
chemically
right,
combined,
and that's a
iron
compound.
sulfide.
Very, very
right,
difficult
and that's
to
a
break
compound.
up. Very, very
If you
difficult
just get some
to break
sulfur
up.
and some iron,
If you just get
mix
some
them together,
sulfur and some iron,
so literally
and you
mix them together,
right?
So
Then
literally
what you can
mix
do
them
is you can
together,
separate them.
right?
Then what you can do is you can
And the way to
separate
separate
those is just to get a magnet.
And the way
bring
to
a magnet
separate
over
those
the
is
top.
just to get a
When you bring a
magnet,
magnet
bring a
over
magnet
the top,
over the
what
top.
it'll do,
When you bring a
it'll
magnet
take
over the top,
and
what
leave
it'll do, it'll
sulfur
take the
in
iron
its
out
place.
and
That
leave
is
the
then a
sulfur
mixture.
in its place.
That is
So,
then a mixture. The question is, what is the difference between an atom,
What is the difference
an element,
between
a compound,
an atom,
and
an
a
element,
mixture? A compound and a
So,
mixture.
an atom
Is the
so,
smallest part of
an atom
element. Is the smallest
An element
part of an element.
contains only one type
An
of
element
atom, and there's
contains
around
only
about
one
100
type of
different
atom,
elements.
and there's around about 100
A
different
compound
elements.
has two or more
A
elements
compound
chemically
has
combined,
two or more elements chemically combined,
and they can only separated by a chemical
and they
reaction.
can only separated
and a
by a
mixture
chemical
has
reaction,
two or more elements,
and a mixture
or compounds,
has two
not
or more
chemically
elements or
combined,
compounds,
but
not
can be
chemically
separated
combined,
using a physical
but can be
process.
separated using a physical process.
Welcome back to Mr. Leek's free science tutorials. This question is now continuing on with the chemistry topic, and it is describe an atom including the structure and relative mass and the relative charge. Now, this is then talking about certain specific parts of an atom itself: the structure, the mass, and the charge. Now, this is basically what an atom is. An atom, right, is made up of a central nucleus, and it contains the protons and the neutrons. Flying around the outside, what we've got electrons, and they're in electron shells. And later on in your years, what you'll do is you'll talk about how many electrons go into each shell. And it's a bit like the sun in the middle and the planets going around the outside, except in one orbit you may well get a lot more planets. So it's similar-ish, but not quite the same. Now, each one of those subatomic particles has got a name. Protons, neutrons, and electrons. What you need to do is you need to know the difference between protons, neutrons, and electrons based on their charge and their mass. Protons, positive. Protons are positive. Kind of makes sense. Neutrons are neutral. They've got no charge. Electrons is the other one. They're -1. Now, these numbers here, the 1 and the 1, right, have no units. And what that basically means is, it basically means that they're relative one to each other. So the proton and the neutron are relatively the same mass. And what you can then do is you compare all the other elements based on the proton having a mass of 1 and the neutron having a mass of 1. The electron's mass is very small, or sometimes it's called negligible. So negligible meaning it almost doesn't exist, right? It's a very small fraction of these other two here. So back to the question. Describe an atom including the structure and relative mass and relative charge. So an atom has a central nucleus that contains the protons and the neutrons. It also has electron shells that contain electrons. Inside the nucleus, we've got protons and neutrons. A proton has a relative charge of +1. A neutron has a relative charge of 0. An electron has a relative charge of -1. The masses of a proton and a neutron are both 1. They're the same. The mass of an electron is very small. That is then answering the question, describe an atom, including the structure, the relative mass, and the relative charge. Welcome back to Mr. Leek's Essential Course. This question is in a continuation of the periodic table. What it is, there are two numbers written next to every element. What are they called and what do they mean? So, this is on the periodic table, right? Now you've got hydrogen, helium, lithium, etc. When you actually get to these sodium has got 23 and 11. What you need to do, you need to know what those numbers actually are. So, what we've got here is I'll just use lithium as the example. Now, the bottom number is called the atomic number. That is then the number of protons in the atom. Okay? Now, number of protons in the atom. And sometimes what I will do is I will write it out as PNE, right? And I call it Preston North End, right? Not that I'm a Preston North End fan, but I call it Preston North End. All right? That atomic number shows the number of protons. So that means there is 3. The number of electrons is exactly the same as the number of protons. So that is also then 3. So in the middle, there's 3 protons. Flying around the outside are 3 electrons. The question then is the number of neutrons. The mass number is the sum of the protons and neutrons in the nucleus. So that would then be 7, take away then the 3, so it's the mass number, take away the atomic number, equals 4. So the number of neutrons in lithium is 4. Okay, so back to the question. There are 2 numbers written next to every element. What are they called and what do they mean? So using lithium as the example. The larger number is the mass number, and that is the sum of the protons and neutrons in the nucleus. The smaller number is the atomic number, or sometimes called the proton number, and it is the number of protons in the atom. That is where the number of electrons is exactly the same as the number of protons. So for lithium, protons is 3, neutrons is 7 take away 3, which gives you 4, and electrons is 3. Welcome back to Mr. Leek's free science tutorials. Now, what we're going to talk about in this video is basically the periodic table. And as you go through your years in science, what you need to do is you need to know mostly 4 different groups on the periodic table, and you need to know the first 20 elements, plus a few others that will be talked about in another video. Now, here we have the periodic table. Okay, now the 4 groups that at any point you need to know about are group number 1, these are the groups across the top, 1, 2, 3, 4, 5, 6, 7 and 0. This big group doesn't have a number, it just has a name. So group 1 is the alkali metals, hydrogen, helium, sodium, potassium, rubidium, etc, etc. Right, they're the alkali metals. This group here are called the transition metals. And this has then got a lot of the ones that you kind of will be aware of, right? But then you need to sort of remember some specific ones. So for example, Ag and Au. Au is gold, Ag is silver, Zn is zinc, Cu copper, Hg is the only liquid metal, all right, which is mercury. Right? There's a number in there that then what you'll do is you'll gradually pick up as you go through. Group number 7 are the halogens. These are fluorine, chlorine, bromine, iodine. And then group 0 are the noble gases. These are the very, very unreactive gases. They are helium, neon, argon, krypton, xenon, radon. Right? So they are 4 groups in the periodic table. This dark line that goes down inside there, right, is metals to the left, non-metals to the right. So you've got aluminium, silicon, and then you've got phosphorus. Silicon is a metal, phosphorus is a non-metal. Boron, carbon. Boron is a metal, carbon is a non-metal. All right. Now, the way that I kind of remember it is you've just got your boron and your carbon. You know carbon is a non-metal, right? And then you just have to kind of remember that boron is a metal. And that's that zigzaggy line that goes down there. Now, the first 20 elements starts with H at the top here, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. Aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. What I suggest you do is I suggest you make a flashcard, right, with those different elements on the back of it, right, and then you write the full name on the other side of it, and then what you do is you just keep testing yourself all the time. You need to know the first 20 elements. So, name the first or 4 groups on the periodic table and the first 20 elements. Group number 1 are the alkali metals. Hydrogen, lithium, sodium, potassium. Second group are the transition metals. The third group is group number 7, fluorine, chlorine, bromine, iodine. Last group, group 0, the noble gases, helium, neon, argon, krypton. They're the only elements that you really need to know in each one of the groups. The first 20 elements are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium.